Okay, hi. Okay, so we are looking at physics here under the topic work, energy, and power. So we have been given a question which came in 2011, section A, question 3. So the question, as you can see, it reads, a girl whose mass is 45 kg carries a box of mass 25 kg up a flight of steps. So there are 40 steps, each 40 centimeters high. So she takes 16 seconds to climb up the steps. We take g as 10 meters per second squared. Then on A, they're asking us to find the weight. As you can see, they're saying, what is her weight? Then on B, they're asking us, what is the weight of the box? On C, they're asking us to calculate the gravitational potential energy of the girl and the box when she reaches the top. D, they're asking us to calculate the power. All right, so now, here we need to understand how we can obtain weight of an object, how we can find the gravitational potential energy, and how we can calculate for power. So now, before we get to answer this question, we are supposed to first of all gather the data that we have in this question. So now, here we need to put into consideration that the masses that we have been given, we have a mass of a girl and also the mass of the box. So this girl is lifting a box to a certain height, okay? This girl is lifting a box to a certain height. So there are steps that this girl is taking, okay? So we assume that maybe this girl is at this particular point lifting a box like that. And then she's taking up these steps until she reaches maybe at this particular point, the top of maybe the floor where she's heading to. Okay, so now the question here, they are telling us that each step, there are 40 steps that this girl is going to climb. Now they're saying that each step that this girl takes has a height of 40 centimeters like that. So the number of steps that we have here, they are 40. So in order for us to know the height that we have, we are going to say that each step that this girl takes is 40 centimeters, but the total number of steps that we have here, they are 40 like that. So on your calculator there, you can say 40 centimeters of each step times 40 steps that this girl will take. So altogether we have 1,600 centimeters. So this is actually the distance or the height that this girl will take as she is lifting this box. So she's going to cover a distance of 1,600 centimeters. Okay, so what we need to do, we need to convert this 1,600 centimeters into meters. So here you simply divide by 100 because we know that 100 centimeters is simply equivalent to 1 meter. So converting this 1,600 into meters, we simply divide by 100, okay, which is going to give us a 16. So here it's as well as good as saying this 0 and this 0 cancelling each other, as well this 0 and this 0 cancelling each other, where you know that a 1 into 16 definitely is going to give us a 16. So this will be 16 meters like that. Okay, so the centimeter and the centimeters you definitely have to cancel there. Okay, so now this is the height that we have. This is the height that this girl is going to take as she is lifting this box. And then now, the other thing that you need to consider is that there are two masses that we have been given. One, there is the mass of the girl and also the mass of the box. So here you say mass of a girl, which is given to us here as 45. So the mass of the girl here is 45 kg, and also we have the mass of a box like that, the mass of the box. So the mass of the box here is 25 kg like that. This is the mass of the box. Okay, so now as this girl is climbing these steps, she is covering a certain distance at for a particular time rather. So the question tells us that she takes 16 seconds in order for her to climb up these steps. So the time taken in order for her to reach the cliff, or rather the top of these stairs here, the time that it takes her is 16 seconds like that, 16 seconds. And then we have been told that we should use our g, which is acceleration due to gravity, we take it as 10 meter per second squared, like that. Okay, so this is the information that we are required to have in order for us to proceed with answering these questions. So now let us look at A. On A, they are asking us to find the weight. So now how we find the weight? We use the formula weight is equal to mass times gravity, like that. This is the formula that we use in order for us to find the weight. So we need to understand critically what the question is asking us to do. So here, the weight that we are finding, they are saying what is her weight. So the key term here is her here. So when they ask what is her weight, they simply mean that we are finding the weight of the girl. So this formula here, it simply means weight is equal to mass times gravity. The M in this formula means mass, the G means the gravity. So this one means mass, and this one means the gravity, okay? Gravity. You can say acceleration due to gravity, like that. So the mass that we are going to use here is the mass of the girl, because we are finding the weight of the girl. So here you say weight is on mass here. We need to understand that the mass of a girl here has been given to us as 45 kg. So mass here, you say 45 times the acceleration due to gravity. We have been guided that we use this 10 meter per second squared. So where the acceleration due to gravity, G here, we are going to substitute with a 10, like that. So you say weight of the girl will therefore be 45 times 10 here, which is a 450 newtons, like that. Okay, and then now we go to B. B, they are saying what is the weight of the box. So we are still finding weight here, but at this particular time, we are now finding the weight of the box, like that. So we are still going to apply the same formula here, where you say weight is mass times gravity, like that. So we use this formula. But now, here we need to put into consideration that the mass that we're going to use here, it's going to be a different mass. So our question is telling us that we find the weight of the box. So we are going to consider this mass of the box, which is 25 kg. We'll substitute it here where there is mass, and we shall multiply with it the acceleration due to gravity, which has been given to us as 10. So you say weight is equal to the mass there is 25. This is the mass of the box, it is 25 kg, times the acceleration due to gravity here is 10 meters per second squared. So here you say 25 times 10. So our weight therefore will be 25 times 10. This is going to be a 250 newtons, like that. Okay, now let us go on C. On C, they are asking us to calculate the gravitational potential energy of the girl and the box when she reaches the top. So now, one thing that we need to consider is, rather what we need to understand here is what potential energy is. So as this girl is lifting this box here, okay, she is in motion, so she's possessing what we call as kinetic energy. But now when she reaches this top here, this top here, she's coming to a stop. So as she is coming to a stop, what is going to be her gravitational potential energy? So in a nutshell, we would say that gravitational potential energy, this is simply the energy that a body possesses when it is not in motion. It is the energy that a body possesses when it is not in motion. This is what potential energy is. So potential energy is given by the formula. You say potential energy is mass times gravity times height, like that. This is what potential energy is. And then we as well need to consider that here we are calculating the gravitational potential energy of the girl and the box. So we need to understand what the examiners are asking us to do. We are finding the potential energy of the girl and the box. And the variable that we have in our formula here, we have this variable mass, gravity, and height. So now let's concentrate on this mass. Since the gravitational potential energy that we are finding, there are for two objects. Okay, we are finding the gravitational potential energy for two objects, meaning we are supposed to find the total mass here. We are going to use the mass of the box and the mass of the girl. We are going to add them together so that we can get the potential energy here. So since we are dealing with two objects, so you say mass of a girl plus, you say plus mass of the box, like that, plus the mass of the box. Okay, so I will say mass of the girl, I'll write it as mg, plus the mass of the box, like that. I'm using them as subscripts, like that. So here we know that the mass of the girl is 45 plus the mass of the box here is 25, like that. So when you have this, you add them, you add the 45 and 25. This is supposed to give you a 70 kg, like that. So this 70 kg implies that we are looking at the mass of, we have a combination rather of the mass of the box and the mass of the girl. Okay, so now let me write this formula. So our potential energy, we are saying that it is potential energy mass times gravity times height, like that. So with the mass that we have obtained here, 70 kg, we are going to substitute it into the formula here where we have mass, and the gravitational field strength, or rather the acceleration due to gravity, we know that it has been given to us as 10 meters per second squared. And the height, here the height that is going to be covered as this girl is climbing these steps here is 16 meters. So what we need to do, we need to substitute these values that we have into the formula. So here we'll say potential energy is our mass for both the box and the girl. We have calculated it is 70 plus the acceleration due to gravity here is going to be 10 times, rather here supposed to be times, and here supposed to be times, like that. Here all the variables here, they are multiplying. Okay, so you say 70 times 10 times the height here, which is 16. Okay, so here you say potential energy is 70 times 70 times 10 here, supposed to be a 700, like that. And then when we multiply it by 16, you go on your calculator, you say 70, which is this one, times 10, which is the acceleration due to gravity, then times the height 16. This is going to be our answer. It's 11,200. So here we have 11,200, like that. So this has to be in joules, like that, because any energy that you calculate for, the SI unit will be joules. When you have kinetic energy, when you are finding work, when you're finding potential energy, all those answers, they're supposed to be left in joules as the SI unit. Okay, so this actually is our answer. All right, then we go on the last question. The last question, they're asking us to calculate the power. So power, in definition, we say that it is the rate at which work is done. So now power is given by the formula where you say power is equal to the work done, or the useful energy, over time taken, like that. Okay, so by using initials, you say power is work, okay, or you say energy, or you say the energy output, like that, energy output over time, like that. Okay, so now here we need to understand that when you have work, okay, when you have work is given to us as force times distance, like that. This is the formula for work. So this work is as well equivalent to the potential energy that we have here. So this work and potential energy, these are interrelated, like that. So what it means here is that instead of us finding the work done here, we are going to say power will equal to the potential energy over the time taken, where we know that our potential energy there we calculated is 11,200 over the time here. When we consider the data that we gathered here, the time that it took for this girl to climb these stairs, it's 16 seconds, meaning what we're going to record here on our time here is 16 seconds, like that. So therefore our power will be 11,200. Then we simply divide with a 16 like that. So 700 is going to be our answer. So our answer here will be 700. Then the unit that we use, the SI unit rather for power here is the watts like that. So therefore you say power is 700 watts like that as the answer. Okay, so this is it. Thank you for watching this video, and don't forget to subscribe to my YouTube channel.